the Coders Campus podcast, where you'll learn how to code from one of the best teachers in the industry. Whether you're an absolute beginner or a seasoned pro, the Coders Campus podcast will teach you what you need to know to master the art of programming. And now, your host, Trevor Page.
Ladies and gentlemen, my fellow coders, welcome to episode 11 of the Coders Campus podcast. Great to have you here. Thanks for jumping on board and actually listening to these things that I'm putting out. Because I do spend, a little bit of time putting these, shows together and everything. And anyway, so today I'm a little bit late. Normally I release these things on Friday mornings, but we are into the afternoon and I'm recording this on the day that I'm releasing it. So clearly I need to get caught up. But again, this is all because I've released a new platform, and I forget if I mentioned this, the specific URL in the last episode. But I built a whole platform around being able to create your own course. So if you're someone who wants to create a course, whether it be a programming course or, a course on cooking or anything under the sun, any course where you're creating content to train someone to do something and you're trying to, bring students on board online, this is what my platform I built is for. So I built it just for myself because I wanted to be able to launch all of my Coders Campus courses inside of this platform. Previously, Coders Campus gave you access to really 4 different main courses and maybe 6 or 7 different webinar series, but it gave you access to those across 4 different URLs. Okay, you'd have to log into 4 different places to go and access the 4 different main courses. And I just felt like this was a really subpar user experience for all of my students inside of Coders Campus. So I built the whole platform with that in mind. I wanted to be able to build my own courses and launch them in one place so that all my students can go to one place, one URL, log in. It's almost like a single sign-on, if you will, and be able to consume all my courses in one place and have it be a really nice-looking platform. So I set out to build that, and I built it. And I even I spent like $500 on a naming contest, so I had a whole bunch of people do a contest to name this application. And it came down to a few good choices, but I ended up putting it out for another vote for people online to see who liked what name the most. And the name that came out above all the other ones was Professo. So I launched a platform called Professo, and it's got a cute little Einstein-looking dude as my mascot, if you will. So you can check it out at professo.com. Professo is like professor, only it has 2 Fs, and F is in Frank, and no R. So PROFESSO.com. And that is my platform right now. If you're listening to this in the present day, which is, September 2016, then you will see pretty much only my courses on there because I haven't yet released it to other teachers to be able to put stuff onto this platform. But that will be coming up in the future, probably the next month or so. I'm going to be opening it up for a sort of a closed beta so that other instructors can come on and create courses. So if you're someone who wants to create a course and either give it away for free or charge money for it and sell it online, shoot me an email, and we can I can maybe set you up as one of the very first beta users for teachers creating their teacher accounts and creating courses. In any case, I've migrated all my Coders Campus students and my Java Supercourse students over to this platform, and so far I've heard nothing but good things. But having said that, the reason why I'm rambling about this is because it's been taking up a lot of time. I've been really sucked into this programming mode, if you will. I've really been enjoying life of late. I love to code, and it shows because I've just been so engrossed in this thing that I've almost taken everything else and shoved it aside to work just specifically on my coding. In any case, if you haven't checked it out, please do so because I'm pretty proud of it. So it's like I said, Professo, PROFESSO.com, and you'll see what the platform looks like. And hey, if you're even interested, you can buy one of my courses. Why not? There's a whole bunch of good stuff on there. You might find something that you like. So check it out. Like I said, I'm really proud. Having said that, let's move on to today's content, which is going to be an extension of the previous episode, which was episode 10. This is now episode 11. In this episode, we're going to be talking about streams again. We talked about streams in the last episode. If you did not hear it, please go back to episode 10 and listen to it, because that will be a crucial step for you to continue listening for this episode number 11. So as promised, I spoke in the last episode about how I'm going to be doing an example on using filters with streams, and yes, as promised, that is exactly what we're going to be talking about right now. I'm going to be diving into another example using streams, but moreover using filters within streams. So we had set up an example of having players that are, playing some sort of a game, and they keep track of their high scores, and the players with high scores live in different states in the US, right? So we were looking at ways to group the people together by state and find the people who have the highest scores in every state. We went through the code to do that, but now let's say we want to do something a little bit different. This time, let's say that we want to get a list of players who are over the age of 20. Okay, so maybe the reason for this is that you want to throw some sort of an adult-only party. So I know the drinking age in the U.S. is 21 and over, so at least I think it is. So that's why we're looking at people of age greater than 20. So that would satisfy our criterion of 21 and over. So let's assume that we have the appropriate age property coded into our player object. Okay, I'm too lazy to repost all the code and everything for, the player object and put this new property in it. But I'm pretty sure at this point we're all familiar with how to add a property, an instance variable to an object, hopefully, right? We know how to do that. So you put a property in, getters and setters for age, make it an integer, very basic stuff. If you don't know how to do that, then you need to go way back in the podcast, probably back to my old podcast to listen to the old episodes. But anyway. So let's assume that we have an ability to get an age for a player. So now how do we get a list of players who are older than 20 using Java streams? Well, it's actually stupidly simple. So we use our players variable because we have the list of players. It's stored as a list of player objects called the players variable. So we do players.stream. Okay, so we always want to stream things. So we say .stream. You can invoke the .stream method on an iterable collection. So since our players is a list collection, that means it's iterable. So we can do players.stream. And then we want to filter. So we just say .filter. Okay, so because you can filter a stream. So when you say .stream, it returns a stream. Then you can say .filter. Filters work off of a stream. And then you can pass in using a Lambda expression, which we learned about, I think, in 2 episodes ago in episode 9. So you pass in a Lambda expression. And I think this one wants a predicate. So I'll explain what a predicate is in a moment. So you pass in, whatever you like as the name of your parameter. So I'm just going to call it P, but you can call it player, you can call it X, you can call it whatever you like. It's just a variable name. So I'll say P, and then I use my lambda symbol, so my arrow, which is the minus sign followed by a greater than symbol. And then I say P.getAge greater than 20. Okay, so that's it. Now I've filtered by that criterion, which is age greater than 20. So we said P.getAge greater than 20. And then we say .collect. Okay, so again, I think when you have a filter returns a stream again, and a stream you can invoke .collect on, so you can say .collect. And then you need to use a collectors. So again, we talked about collectors, this utility object, if you will, full of utility methods. You can use collectors.toList. So essentially you can say collect the remaining items that match this filter and collect them into a list. Okay, so in other words, you're returning a list of objects. Okay, so and that's really it. There you go. You've now returned a list of players of whom are greater than age 20. So they are adults, hypothetically speaking. So yeah, there we go. That's how you use a filter method. Super straightforward, right? So the filter method takes, like I said, one parameter. It takes a predicate object. And I promise I'd talk about what a predicate is. So a predicate is a special interface provided by Java as of version 8. Okay, version 8 brought a whole bunch of new toys to play with. The predicate interface is one of the toys. So recall that we talked about another one of these special interfaces in the last episode. It was called the consumer interface. All right, so previously we were talking about consumer interfaces, now we're talking about predicate interfaces. The difference between a consumer and a predicate is that the consumer doesn't return anything, right? So we were using consumer for, what was it? Were we sorting? Or I forget what let me scroll up and see what we're using the consumer for. Or were we grouping stuff? I cannot remember. I think we were grouping stuff. That's what took the consumer. I believe so. Or maybe it was the comparator. I can't remember anymore. This is how bad my brain is. So the difference is the consumer doesn't return anything, but the predicate does return something, and specifically it returns a Boolean. Okay, so the predicate is like a test. You're testing something, and it's going to be tested. It's going to return a true or false depending on that test. Okay, so this is important because if we were to code a method for filtering, if we were to sit down and write the code ourselves, we would need to return a Boolean value to say if we should or should not include a particular data point in our final set of, or final collection of values, right? So this is why the filter method takes a predicate. So if we were to peek inside what an actual predicate looks like, so we look into the Java 8 code, you would see basically it's defined as a functional interface. So remember, we were talking about functional interfaces in the last lesson, I think, or maybe it was a lesson before that. Yeah, I think it was maybe lesson 9, or rather episode 9. We were talking about functional interfaces. They are an interface that have a single abstract method, a SAM, single abstract method, SAM. So there we go. So this predicate interface, when we take a peek at it, you'll see it's annotated with the @functional interface annotation to say, hey, this is a functional interface, so it should be able to work when we're using Lambda expressions. You should be able to use it in a Lambda expression. And it's a public interface. It's called predicate, and it defines a T template, a generic T, right? So it doesn't take it declares it, because inside of the predicate methods, one of the methods is Boolean test, so it returns a Boolean, and the method name is test, although we don't really care what the method name is. And the test method takes a T object, okay, so it just takes a generic type. You can pass in whatever type you like for this test. So using Lambda expressions, we can concisely write out what an appropriate filter would look like we did with the code that I already explained. So we say .filter on a stream. We say P Lambda symbol p.getAge greater than 20, right? That's what we did. So we're able to do that because it's a predicate. The predicate interface takes it expects a Boolean method, or method that returns a Boolean that takes a single T object as a parameter. So the parameter we're passing in is the P, which is the player parameter. Okay, the player is of type player, and the type player is going to be what the predicate is accepting as the type T, right? So T is a generic object, and we're passing in a player object. So there we go. This particular instance, when we're using the filter, the predicate interface that we're invoking the test method inside the predicate interface, and we're passing in a player object. So we name that as P. And then we're saying that's the method for the body of it. The body of it is p1.getAge is greater than 20. Okay, so remember the body of the predicate, the body of the test method in the predicate interface needs to return a Boolean. Okay, so we do that. We say p1.getAge greater than 20. I keep saying p1. I've written down p1 in the code. That's incorrect code, Trevor. I need to go back and adjust that on my article, because I declared it as p, right? So I shouldn't be saying p1. I should say p.getAge greater than 20. But the whole point is p.getAge greater than 20 is a Boolean expression, right? That's going to return true or false, which is exactly what our predicate's test method wants from us. All right. So now, while I'm saying all this stuff, I'm going to go into my code here, and I'm going to update my blog post so that it is correct, because that's been correct since for the past week or so that it's been out. So let me look. I say p1.get something. So here is the code. I need to say not p1, just p. There we go. I've corrected the mistake. Just like that. Real-time correction of my mistake. So anyway, and then we do our collect method. We fire it off, and we collect everything using the collectors.toList utility method, which is to convert the data points into a list of players. Okay? Super, super simple, super fast, love it to death. I'm really falling in love with streams the more I see them and the more I play with them, the more I understand them. The more I'm just falling deeply in love with this stuff. It's just this stuff alone, streams and lambdas and all the stuff that we can do now in Java 8 has converted some of the Java naysayers into believers. So people that now believe in the Java platform or Java language, and they're now going back to it and using it again. So we're converting non-believers into believers with this stuff. Pretty cool. All right. Next up is an example using the map function. So I forget if we talked about map already in our previous example from episode 10. No, we didn't. Okay, so we've talked about the collect method, which is sort of what we do at the very end. We do a .collect, which actually executes all the previous stuff that we had done on the stream. We talked about that. We've talked about using the filter. So we filter before we collect. Okay, but you can also map before you collect. All right, so we've seen how to use, like I said, some of the neat utility methods with the collector's object, and we've seen the filter results example. So now let's have a look at how we can use the mapping functionality with streams. So with the mapping function, you can translate your larger data set into a smaller one and return it. And by that I mean narrow it is what I should really say. You're taking, I don't believe that the data set will change in terms of the number of data points, but what you're bringing out of the data points will change. So I'll give you a great example. So a great example can be shown with, let's say, get player IDs method. So we'll build a get player IDs method. Okay. So let's assume that we want to get a list of player IDs, and we can stream them and return them with the map function. So like we want to get all the IDs of the players in a list of players. So this is what I'm talking about. I'm talking about not reducing the data set into a smaller one, because that's what I say. It's kind of a misleading way of saying it. We are taking the whole data set, the whole player data set, and sort of narrowing it down. Instead of returning the whole player object, I'm just returning, let's say, the IDs. So a list of long data points, right? A list of longs, if you will, or a list of integers. Okay. So we're mapping down from a whole player object to just the ID. Okay, that's what I mean by mapping. So what you do is you just say players.stream. Okay, always, whenever we're doing the stream stuff, we need to invoke the .stream method. And then we say .map. And here what we can do is we pass in exactly what we want to get out of this mapping equation. So in this case, I'm going to map using the a method, what's this called? By passing in a method signature, right? So I'm passing in player : get ID. Now, have I talked about the : syntax? Let me look up and see if we've talked about the : Yes, we did. So we talked about that when we were talking about getting high scores and all that stuff. Yes, we talked about the : So it's just a method reference, right? We're passing in the reference to a method to the mapping method. So players.stream.map, and I'm passing in player : get ID. Because the player method, or the player object, I should say, the player object defines a get ID method. And that's exactly how we want to map our data set. That's what we're interested in. We're just interested in getting the IDs of the players. Okay, or from the players. So we pass in player get ID with player : get ID. Now you could probably pass in a lambda function for this. You might be able to pass in like, p lambda expression, or arrow, and then p dot get ID. You might be able to do that, but it's cleaner to pass in a method reference. It's faster. It compiles faster, I believe. So it just looks better that way. There's less noise going on. Anyway, and then finally we do a .collect after we've done the .map. We do a .collect, and we pass in collectors.toList. Okay, so collectors.toList is that handy utility method or object, and then we pass in a toList utility method. So it does collectors.toList. It'll, take all of our stuff from the stream and collect it back into a list for us. And what it's going to return, since we invoked the mapping function, it's not going to return a list of players. It's going to return a list of long objects, because the player IDs are mapped as a long value. Okay, so it's going to get a list of longs, which is just what we want. We want to get a list of player IDs, which is a list of long. So hopefully that's fairly, straightforward to understand. Like I said, the key here is that we're wanting to just return the player IDs. So we use the map function to facilitate the translation from the player object to the long object. Okay? Really, really cool stuff. So let me give you another random mapping example to hopefully clear this up in your head if it doesn't make any sense at all. There are other mapping functions that we can make use of as well, like, for example, the map to int method. Okay, so let's talk about a simple example. So let's say we have a stream of strings. So we have an array of strings or something like that. Or a list of strings. So the strings are, A1, A2, A3, A4, A5, whatever, right? We have a whole bunch of strings with an alpha character or alpha characters and then a digit. Okay? So let's say we just want to extract the digit from this stream, okay, from this list of strings. This is a fairly common thing that I do, at least in JavaScript anyway. I'll have I'll give an ID to some sort of an element on my HTML page, and the ID will be, player 1, player 2, player 3, player 4, because that way they're all unique IDs. And what I want to do is I want to be able to extract just the player ID from that string, right? So player 1, player 2, player 3, all I'm interested in is getting 1, 2, 3. Not player 1, player 2, player 3. I want to get rid of the word player. So this is a good example of that. So we can say, we can have a stream of strings. So we have, like I said, A1, A2, A3, A4, A5. And then we can do, dot stream. And then we can say dot map. So let's think about this. I have a data set that's filled with A1, A2, A3, A4, A5, etc. And I want to not reduce it. I want to translate it. I guess that's a good word, or transform it from what it is, an array of strings or a list of strings, and I want to translate it into just the numbers. Okay, so how would we do that? What sort of body code would we write in to make that happen? Well, if you have A1, A2, A3, you might just do a substring. Okay, you might do a substring to say, substring, and then you pass in the number 1, because what that would do is it would say, the substring 1 would mean get me a substring of this string starting at the first index, which is actually the second position. In other words, it'll just return 1, 2, 3, 4, 5, etc. Right? You could also do, a split or something if you know that, you could split it by the letter A. I don't know. It's up to you, right? However you want to implement this. But for this example, I'm going to use a substring. So that's how I would get the number out of that string. So how do we put this into our code for this translation of mapping thing? So again, we do the stream. We have the stream that we're dealing with. So stream dot map. And then we pass in a translation. So we do S. Okay, you call it whatever you like, but I'm going to pass in S, and then pass in we do S, and then we do the Lambda expression, and then we say S dot substring. Okay, and then pass in the number 1. So S Lambda S dot substring 1. So that's the translation that we're doing. We're taking our data set of A1, A2, A3, we're mapping it to just the substring with number 1, which means we're just getting the string 1, 2, 3, 4, 5. But then what I want to do is I want to take the strings 1, 2, 3, 4, 5, because remember, it's going to map this to essentially an array of strings, 1, 2, 3, 4, 5. But now I want to get the integer value. So I can say dot map to int. All right, so it's going to turn it into an int, map to int, and I pass in integer parse int. All right. So when we pass in integer parse int, that means we want to parse an integer from the string. Okay, and that's exactly what's going to happen, because if you were given a list of strings that were inside the strings there are 1, 2, 3, 4, 5, how would you turn that into an integer? Well, you'd have to say integer dot parse int, and you'd pass in each one of the values. Right? That would parse it and turn it into an integer. But here we can say map to int, which is going to return an integer, and we can pass in the map to int, it wants some sort of a method to invoke to actually, do that translation, and the translation that we're doing is integer parse int. So we're passing in a method reference to the integers parse int method. Okay, so this is going to return a stream of integers. Specifically, it's going to return an int stream. It's a special type of stream. It means it's just integers. So you're going to get a stream of integers, which is essentially 1, 2, 3, 4, 5, whatever. And then, if you want to, you could even perform more operations on it. Maybe you want to get the maximum value or something like that. So you can say .max, or maybe you want to get the first instance. I think you can do that with .first something. I think find first, I believe is what it's called. You can say .find first, and it'll find the first element in that stream of integers, or what have you. Right? You can do whatever you like, or you can collect them to a list if you like. You can do .collect and say collectors.to list. You can do whatever the heck you want to do with it. All right. Beautiful, beautiful stuff. It's really, and also it reads nicely as well. When you're looking at it, you can see, okay, you're starting with a stream, a stream of strings. You can see what the strings look like. You're saying .map. You're turning it into, we're just doing a substring on it. Okay, so I understand what a substring is. We're mapping it to that substring. Then we're saying map to int, and we're parsing the integer value. Okay, so I can see we're taking a string and turning it into an integer, and then we're doing whatever else. So if I were to look at this code, I can say out loud exactly what's happening. But if I were to write it in Java 7 code, there would be a whole bunch of different for loops, and it would take me a lot longer to be able to say exactly what was going on with this whole process, which is why this streaming stuff and this functional programming paradigm stuff is really quite neat. It really does make the code more readable. Now, yes, it's a bit more complicated right now because we're not familiar with it. Fair enough. That's perfectly fair. But that's just because you're not familiar with it yet. You haven't used it enough. As you become more familiar with it, you're going to realize it's not actually that complex. All right, I said in the last episode that this stuff was complex. It's not necessarily true. It's not complex. It's just unfamiliar. Okay, so you just need to get more familiar with it. You need to use more examples. You need to use, just use it in your code base. Anytime you are iterating through a collection, stop and say, wait a second. Can I instead invoke the stream operation and stream this stuff? All right, so good question for you. Now, I think I'll wrap things up for this episode by talking about the parallelization, which I was sort of mentioning in the last episode, where you can do parallel streams. So the kind of the crappy part, if you will, about about creating concurrent code is that if you were to be given the task of making code work concurrently, so in other words, multi-threading and whatnot, in the past, your code is going to make quite a substantial transformation. Okay, there's the code that you started with is not going to be what you're going to be ending with once you put all the code in to make it concurrent, right? There's a whole bunch of stuff that you're going to need to do, and it's just going to make the code a lot more complex. But what's really super cool about streams is that doesn't happen when you want to make your stuff concurrent. All you need to do is, instead of saying .stream when you're streaming, an iterable collection, instead of saying .stream, you say .parallel stream. And that's it. You've just turned all the operations that you've already written. You don't have to change any other code. Everything now is is executed concurrently. It uses their concurrent code where possible. Okay, so this is super useful when you have a huge data set. So if you were, working with, over 10,000 elements, data points in your collection, then using concurrent streams is probably a very good idea. So parallel stream would be a good method to use. This is just a ballpark, a rough suggestion, if you will, of when to use parallel streams. But another good use case for parallel streams is if you're doing like a lot of web calls. So if you're doing a lot of HTTP GET requests and stuff like that, if you're doing a lot of API calls or something like that, it works really well when you're using a whole bunch of API calls. So if you have a bunch of a big collection, or maybe not even that big of a collection, but if you have a big enough collection and you need to do a whole bunch of API calls for each of those elements in the collection, doing a parallel stream is probably going to be much faster than just doing a normal stream. Okay, one at a time type of thing. But now I urge you to realize you shouldn't just blindly put in a parallel stream anytime you're working with a collection and using a streaming of collections, because there's a lot of overhead with the parallelizing of the code, and it can slow down your code to the point where it's a lot slower than if you were to just use a sort of synchronous stream, so the regular .stream method. Okay, so be mindful. Like I said, if you have a giant data set, then yes, that's a good candidate for parallelizing. If you have API calls and dependencies on the interwebs, then yeah, that's probably a good candidate as well for parallelizing your streams. All right, but like I said, huge gain in speed, and all you need to do is tack on the word parallel. How simple is that? I absolutely love this stuff. Blows my mind that we can do this stuff now with Java. So super cool. Okay, so I think that is good enough for now. I think in the next episode I'll dive into the optional stuff, like I had talked about before, and the optional keyword and how sort of cool that thing is, and how we can use it to get around null pointer exceptions and whatnot. So that will be hopefully a highly used keyword in future code whenever you are writing your new pieces of code, so that we can get around and not have to deal with null pointer exceptions anymore. Wouldn't that be nice, ladies and gentlemen? For sure. So we'll talk about that in the next episode. If you haven't already, like I said, check out the Coders Campus website. You can go to coderscampus.com/11 for these show notes. But really, this 11 is just going to forward you to episode 10, because that's where all my notes are. But whatever, you can go to /10 or /11. You'll see all of the stuff there. Or, like I said, just check out Coders Campus in general. If you are loving this content, if you're someone who is looking to either, if you're just a very beginner with coding, that's fine too. That's what Coders Campus is for. I have a lot of lessons in there that teach you Java from the very beginning. So I talk about, what is a variable? What is a for loop? What is a, while loop? What is an integer? What is, I talk about that from the very basic level all the way up to what we're talking about now. I have a gigantic library of videos. I think I have over 150 hours of content in there. It's just gigantic. So there's something in there for everyone. I would highly recommend checking it out. coderscampus.com. You can sign up there, or you can go to professo.com and you can see all my different courses that I have, and you can pick them, piecemeal if you like. If you just want one course, then you can just take one course. But Coders Campus it's a monthly membership, and it gives you access to everything I've ever done. Okay, that's why Coders Campus, the monthly membership, is so cool. But hey, some people don't want to subscribe for the whole month or whatever, or many months. They just want one course. So you can go in and you can go to professo.com. Again, 2 F's, 2 S's, 1 O. Or is it not? It's not 1 O, it's 2 O's. 2 O's, 2 F's, 2 S's. There we go. And 1 R. Anyway, professo.com. You can go there and check out all my courses on there, unless you're listening to this very, very far into the future, in which case the Professo will have a lot of courses on there, and then you'll probably need to go to some other URL just to see my courses. But anyway, that's future Trevor's problem, right? Right. So, hope you enjoyed this episode. I look forward to seeing you guys in the next one. Always a blast doing this kind of stuff. So, yeah, can't wait to see you guys there. So take care of yourselves, as always. Happy learning, and bye for now.
Thanks for listening to this episode of the Coders Campus podcast. But before you go, Trevor has a favor to ask you. In order to keep these episodes free, he'd love for you to leave a rating and review the podcast on iTunes. Just go to coderscampus.com/review to leave your own rating and review of the show. So if you have 30 seconds to spare right now, please help out by leaving a rating and review via coderscampus.com/review. It will ensure that you continue to get these awesome free podcast episodes each and every week. So if you like free swag, head on over to coderscampus.com/review. Happy learning!